You should get the notice.
Yeah, hi everyone. Thank you so much for being with us today. It's a great pleasure to introduce my very good friend Tariq Masood. Tariq is now a professor in Glasgow at the Department of Engineering. He spent most of his career in Cambridge, where, among other initiatives, he founded multidisciplinary research program on the industrial systems of the future and disaster resilient in operations. And I would like to mention that Tariq brought me once to the automation lab in Cambridge, and it was absolutely exciting experience. These programs have been instrumental in engaging with industry across the globe extensively and also successfully producing several high-caliber research students. Tariq is passionate about human-machine interactions, and particularly in the context of smart factories and industry 4.0 technologies. He has published numerous books, chapter, conference paper, and articles in leading journals, AI, among others, Science Robotics, Robotics, and Computer Integrated Manufacturing, a Manufacturing Journal of Manufacturing System, International Journal of Producing Research. Tariq sits on several editorial boards, again, among others, editorial advisory board of the IET, Collaborative Intelligent Manufacturing Journal, and is an academic editor of the PRJ Computer Science Journal, where he handles articles on human-machine interaction. Is also currently guest editor of the special issue on Industry 4.0 Technologies for Global Challenges and Computational Modeling and Design of Energy Systems in Energy's Journal. And today Tariq is going to talk about the future of human and machine interaction. Please, Tariq, so the floor is yours.
Thank you very much. I'm very humbled with your detailed introduction, and thank you very much for inviting me to talk here today. Hello, everyone. I'm very pleased to be here, and I will be talking about the future of human-machine interaction. Gulia, could you please rise to share screen so that I can share my slides?
Yes, wait a sec. Moment, yeah. Yeah. Yeah, now it should work, I think. Yeah.
Yes, thank you very much. So, the main thing that we will be talking about here is about the future of human-machine interaction. So that's the main aim. If we divide it, we are talking about the human and machine aspects and how they interact with each other. And the main aim of the today's talk is to explore what it could mean in terms of the future and so on, based upon the previous latest research, as well as the actions that have been happening in the past. So I thought that it's a broad topic, and it could mean many different things to different people, and particularly when we are talking about cross-discipline. So let's think about some key questions here that could provide a framework for today's talk. Though coverage would be at an overview level, but I will go into further detail for some of these aspects here. So I thought one question could be to understand what is meant by human-machine interaction. And another could be about what are the challenges in terms of design and operation of these sort of human-machine interaction systems, and how to overcome those sort of challenges. And that would link to finding out what is the future of human-machine interaction in that way. So when we look at the human aspect, we are talking about the social aspects, we're talking about the psychological aspects, the things that the humans are more comfortable in doing, how they understand things, how they perceive things, and how they convert those sort of perceptions into actions, and how they do things at the end, based upon all the intelligence that they get, and so on. So there's a whole domain where we can talk about the human aspects. Um, there has been a lot of work, but we're still learning about the human interactions, human perceptions, and human intelligence, and so on. But on the other hand, when we look at the machine aspects, we are talking about those sort of when we talk about making things, where we use machines in terms of making things, we're talking about processes, which processes they can automate, for example, which technology could be used, for example. One example could be robot, another example could be a computer numerical controlled machine, or similarly the other machines we interact with on more daily basis. And and whenever we talk about these sort of machines, we can also think about the systems perspective, where we see number of machines working in an environment, either collaboratively or separately, but they are kind of making an environment a hub or an Internet of Things type of concepts. And when we talk about the interactions, we are thinking about the interaction between these two different types, human on the one hand, while machine on the other hand. And machine in this way kind of imitating the different capabilities, the actions, the intelligence that humans have, or in other way could be taking out more boring aspects or some useful aspects in other hand, which are useful for humans on the other hand. Some very basic examples of the human machine interfaces which are used for enabling the interaction could be like the ATM machine to get the cash out, or touch screen like the iPads or notepads, or even on the laptops you can touch the screens and so on. When you go into the store, you can see the details on the store. You can operate them with the touch screen. We can think about the robots, obviously, the computer numerically controlled machines, or programmable logical controllers on the other hand. So those more industrially manufacturing oriented interfaces in that way. In order for these things to be enabled, we need more sort of networks sometimes, which connects different different interactions, different machine-to-machine interaction, or on the other hand, there might be human, which is operating the machine, but the machines are interacted, and the other human may be on the other side. So you can think from that sort of coupling, the human-machine coupling, which needs some sort of network, either it's an industrial network or Ethernet, to connect devices, which can form industrial Internet of Things, or these might be simple users sitting in their homes and interacting with the home-based technologies, which can control the environment, like the heating and other aspects, or device control mechanisms they can use within the homes. So there are a number of aspects which we can consider. So what's the future about these? Where we are going based upon these, we will talk about these. On the other hand, I would like to put a framework in terms of what we can talk in today's talk with the limited time. I thought I will touch on three main things. The artificial intelligence, the AI, how the machines are imitating the human capabilities, how those are being automated and so on. And particularly talking about robotics, how robotics is playing its part in terms of going towards more knowledge-based, cognition-based systems, where you can bring more intelligence into the systems. And the third one is about the augmented reality, which might also be linked to the human augmentation on the other side, where these three things could also link to the human augmentation if that is happening on the other side as well. So let's talk about the AI first. So we have seen all the internet revolution, all the computers, laptops, and all the other devices, the computing devices. The processing power has increased in the last 2-3 decades. Based upon those sort of new advancements, we have been seeing these sort of algorithms built into the computer systems, or different types of computer systems, where we can use the technology for the betterment, or it might go worst. So there are both perspectives. So you can think about how best you can use it for the good, but also you need to protect people from the wrong use of these sort of algorithms as well. So some very basic examples could be using the different types of apps, for example, for counting objects, where the AI-based apps can figure out what sort of pictures or figures they are seeing through the camera, and then they can count them as 1, 2, 3, 4. Very basic app. On the other hand, we can think about a bit more advanced version of that, where we can think about the driverless cars, for example, where the algorithms are much more sophisticated in terms of controlling the whole car and thinking about all different perceptions based upon different objects coming into way. You can think about, if you would have, if you're a driver, you would know what sort of different circumstances you can face, what sort of variation you can see on the road. And that sort of program needs to cover all those sort of variations, expected, unexpected, and so on. So how can that learn? How can that that sort of artificial intelligence could be embedded into the system with all those sort of deep learning and all the other different types of programs, algorithms on the back. And similarly, you can think about the use of AI in wider aspects of life. There are lots of examples. You can see the use of AI in hospitals, particularly in the face of COVID-19, where people have been using the AI based tools, linking with the big data and other aspects to look into the demands of the hospitals and so on, so that they can meet those sort of demands in the times of disasters and so on. And there are other aspects linked to the AI where we need to be aware of all the cognition debate linking to the cognition, that whether AI need to be empowered in a way that can take decisions and might become more powerful than the humans and so on. So that's a long debate, it's an ongoing debate. But more pertinent issues, other issues are about data ownership. Who owns such sort of data where devices are linked to others and your data is being transferred and so on. Privacy issues are there. Cybersecurity or control related issues are there. What if someone controls the software that is running the driverless car? And there's an accident, for example. So who will be responsible? All those sort of legal issues are also there. But if we look at on the back, the technology is basically making use of different images or objects, and by recognizing all these variations in terms of images and automatically recognizing them and then feeding them into their intelligence decision-making processes to make certain decisions based upon the rule bases that have been developed on the back end. So this is quite key in this sort of machine learning and deep learning sort of space where the AI is taking us. And when we talk about these sort of different dimensions, we are actually talking about big data or open data sort of space where where there are huge volumes or there's a high velocity of data, there's variety of data, and there are other aspects related to the big data and so on. And we are talking about putting this sort of data, information, or knowledge into different sorts of cloud technologies, which is quite common nowadays, and it's kind of a future where most of the data will be placed when it will be huge and so on. And we are basically talking about the digitization and automation of knowledge here, where all the knowledge that is otherwise embedded into human mind and the processes done within the human, we are putting that into the machines so that machines can process that sort of data, convert it into information level, and make it up to a knowledge level where the machine would have actionable understanding, where it can take actions based upon different algorithms in terms of artificial intelligence and machine learning and so on. So all that sort of debate is there. We have seen that the most profit-making companies nowadays are based upon data-based models, where they are processing data and making use of that particular data so that they can convert it into more AI-based models and so on. This is just an example of a Siri at MacBook Pro, where you can, most people would know who are using Apple MacBooks, where you can basically ask Siri to find some places, and how good it is in terms of finding would be based upon how you have trained the machine in terms of your voice and so on. So there are those sort of aspects are still there in terms of training the systems, and then systems are becoming more and more intelligent based upon your training of the data. And that leads to the analytics part, that there are a number of different methods which could be used in terms of making the machines more intelligent. And those sort of methods might be coming through neural networks or very simply from data or text mining and machine learning algorithms or pattern matching. We talked about the pictures and so on. And visualization, different visualization techniques, how can you forecast things and so on. And there are lots of other different simulation-based and complex event processing algorithms are there. But it's a long debate in terms of AI. There are lots of methods, there are lots of things happening, and they are pushing the boundaries beyond, based upon the advancement into the hardware and software technology, which is mainly driving the future towards going into more and more intelligent based. And we haven't talked about the human augmentation here, or where you can read the minds, or you can link more into the human bodies. You implant things and so on into the human bodies, which is another debate. But let's talk about the robots that links to making the machines intelligent. And we talk about robots quite a lot in this space. And there are many useful robots which are used in daily life as well. And some of the examples are here based upon the evolution of robots. And based upon those daily life-based robots which are helping the humans in carrying their tasks where they can't do on their own, for example, or they do the tasks in collaboration with them. By the way, I'm not talking about the industrial robots here. They are a different species, another type of robots, but starting with more overall, more combined view of that. So in this one, you can see some of the industrial robots here as well. We have seen them working in, for example, car manufacturing industry quite a lot, and there are other different types of industry using robots and so on. And particularly, I would like to talk about a new species, a relatively new species of collaborative robots or cobots, which is quite emerging nowadays. When we talk about the collaboration between human and machines, here we are talking about human and robot collaboration. So it's called collaborative robots or cobots for the short. And there are advantages in terms of using there are the pros and cons, obviously. Where you need more dedicated, bigger robots, more rigid robots, obviously you would go for those. But where you need more more changeable, reconfigurable sort of circumstances, you might want to look into collaborative robots, or where you want more assembly related tasks, or where the safety restrictions are not that high, um, based upon the speed of the robots. Then you can think about those sort of species. Uh, but mostly cobots are used when we look at different literature. We look at natural control of cobots sort of interest area in the research communities. They're also interested in operational impact of it and safety. So these three areas are um, quite widely talked about, and there are others in here as well. So one particular question that is asked here is how human workers perceive cobots utilized in their workspaces, and similarly, how accepting users are to collision avoidance strategies and suggest improved motion control algorithms to improve the human experience while working with robots. So there are a number of questions here where you can look into how humans are making the machines as their working partners in this case, because they can work hand in hand in this particular case, as opposed to the traditional robots which are bound in a cage, and the humans cannot go into that cage due to safety restrictions and so on. So I would like to highlight a particular example here in terms of COVID-19, when everyone was looking at in the start of the, particularly in the start of the COVID-19, when everyone was trying to find ventilators or build ventilators and so on. So there was quite a high demand based upon the understanding, and still there. The demand is still there. But at that time, several countries, they looked into making new ventilators, ramp up the production and repurpose different factories and so on. And UK Ventilator Challenge was one of them, where tens of different large and small companies came together to design, develop, and manufacture new ventilators. And it was amazing to see how totally different type of production units they were used to produce totally different types of products. For example, racing cars, jet engines, and vacuum cleaner manufacturers, they made ventilators by repurposing their production plants. However, the whole task was challenging, of course. And there were challenges, and particularly one thing was to look into and keep the social distancing so that the humans, they are safe. And one idea that we proposed and is published in Science Robotics and Journal of Flexible Manufacturing Systems is about making repurposing factories with robotics in the face of COVID-19, so that we can ramp up the production of medical ventilators in that case. So here you can see the different parts of a ventilator assembly. And if you look into how these parts could be made, you can look at this sort of layout where the humans are working with robots here. So you can see in this particular cell there are two robots and two humans here, and you can ensure that there are social distancing measures are in place, because you are basically making the human presence, you're reducing that by 50% in this particular case by bringing the collaborative robots here. And they have advantages in terms of they can quickly move to new places, they could be easily used, they are portable, they are they are cheaper than the other bigger robots, so they're economical in that ways. So what happens is, in this case, you can see normally when we talk about robots, they do pick and place. That is one particular type of robot activities, that they pick things and they place things. They could do other activities as well, but in this particular case, we simulated this scenario using the robot activities, which pick and place activities. There were 6 tasks with the timings here, which were needed and to be done by a robot or cobot in this case. While there were other tasks from 7 to 14, which were to be done by the humans. So they were all assembly tasks in this particular case. And you could see that in the manufacturing environment, you can use these sort of different stations, different human-robot collaboration cells, where they can work together to repurpose the factory and to make them with more speed and ramp up the production in that particular scenario. And this was here is a video that you can see, a short video to see them in action. So this was just an example of how the cobots could work in this sort of scenario. And this is kind of a future in terms of the manufacturing domain. There are other technologies in the fourth industrial revolution, Industry 4, which started from Germany. And that sort of, that has taken the whole world in terms of making up their own versions of Industry 4.0, which includes roughly 20 plus technologies, which I'm not covering all of them in today's lecture, but there are lots of them, and you can think about all those technologies, how they are contributing towards human-machine interaction and its future. But when we talk about the touch interfaces and different types of user interface, the graphical user interface, we can think about these key user interfaces are around the voice control, the acoustics. It could be around optics using the eye control. It could be bionics based upon, again, so this one is based upon light, and this is based upon the eye, and then the motion control and the touch control, which many of us already are using based upon the iPad and notepad type of technology or mobile technology, smartphones and so on. I'm going to talk about a particular case of augmented reality as an interface. Just very simple, starting from very simple example. I don't know if you know about Thomas and Friends. It's a character for children. It's a train engine. There's a fat controller who controls different engines, operates and manages them. And in this case, I'm just going to show you about some sort of experiment that I did with this by putting this filter on it. So in this case, this is a physical thing, a physical engine, a toy engine. And this filter is virtual, it's not physical. So which means we are combining the physical thing with a virtual thing. And that's how we are augmenting one thing on the other, the virtual thing on the real interface, real thing. And this is common. So you might have used it, this sort of technology before. The AR sort of filters are quite common in smartphones, and there are filters in Zoom as well. You can see some of the filters I'm not using now, but you can try them afterwards. You can find different filters over there if you haven't used them. But coming back to this, the one thing I wanted to highlight here was, so this is another engine, it's called Percy. So there are two engines. So when I tried to put this filter on Thomas, it was very quick. It was not very quick, because if you see here, if you see the eyes of Thomas, they are a bit tilted towards the nose. So this means the technology which is looking for a face here was a bit not perfect in a way to identify this as the face. So I had difficulty to mask it with this filter. While in this one, the Percy, you can see the eyes are quite normal in this case. So it was very quick. So when I put filter on, it went very quick, and I experimented with many different versions of this. So the main point here is that this sort of technology needs training, and those sort of trainings are quite key when we talk about the human-machine interaction or virtual interaction, the augmented reality in this particular case. And when we talk about at industrial scale, there are challenges in terms of the technology itself, where we can talk about the software, the hardware, the ergonomics aspects, how you use them, how heavy it is, what's the field of view, and so on. Excuse me. While on the organizational level, you can think about the user level, how the users are accepting, they're adopting the technology, what are the privacy related matters, and so on. The company level, you can think about different shop floor processes where there are benefits, but there are challenges as well. How you can change the whole processes, how people are using the processes. So the normal process is that you're issuing the paperwork so that the instructions, so that people can do the work. But in this case, you're putting the headset on, and all the processes are shown virtually inside the glasses. So you can take out all the paperwork as well. So that could be an advantage, which can provide flexibility as well. Most of these applications, if you look at the literature, are being used in assembly, manufacturing, logistics, and quality areas. But there are other examples as well when you look at the other literature. So this is only focusing on the manufacturing related processes. And when you talk to industry, for example, as part of an industrial survey, we found that the key challenges are the key high importance, high relevance areas are ergonomics related area, where you see the interaction, how humans they are interacting with the technology and using that particular augmented reality devices, and the usability of the interface, and the user acceptance, visibility of information, because the eyes are extensively used, the efficiency improvement, and so these sort of areas were quite important in that way. So this highlighted the challenges in terms of user acceptance issues, the compatibility issues, the hardware related and content creation difficulties, because the devices are there, humans are there, but the content, the virtual content is not there. You have to create it. And similarly, these are linked with the key success factors, which can ensure that the technology adoption is a success in a particular scenario. So just to give you an idea of how it works, so you can see this thing, virtual thing through the headsets. If you put the headsets on your eyes, on your head, you can see this sort of interface where you can go through different processes. In this case, I'm showing you a 3D assembly, which is shown here. So this is going through different processes to assemble a gearbox, a very simple gearbox, which would look like this when assembled, kind of near assembled. And we did some experiments based upon these in the industry where we used these headsets, which you can see in the middle picture. And using this headset, we asked people to assemble these 3D gear assembly, uh, both operators and non-operators, so that we can find out what are the challenges they were facing and all different aspects that we have been talking about. There were 22 experiments that we did, and we also used some university students as a control group, so that we find out what's the deviation from students with the others. So these experiments, we recorded responses using a commonly used index. It's called Task Load Index, TLX, devised by NASA. And based upon this, we find out these sort of different timings with NOP as non-operators and OP as operators. For example, in terms of mental demand, you can see that non-operators, they found they took a little bit more time than operators in this case, and the range, the operators range is a little bit more. And similarly, there were like the temporal demand, the operators and non-operators were quite of same scale, but the range was more for non-operators here. And you can see the other sort of domains here. You can see in the performance, there's a big difference in terms of operators and non-operators, where operators took less time. While in terms of frustration, non-operators were much more frustrated in terms of range than the operators. And there are other aspects that you can see, all linked with the ergonomics where human-machine interaction was happening in that way. So this is one example that I wanted to highlight, but what about the cognition? So we talked about AI, robotics, and augmented reality so far. So how do all these relate? How do they come together to form the intelligence? How do you pick up things and make something out of it and convert that from human to the machines? How do you process data or information? I think that's key. How do you convert it into knowledge is quite key. And that's where things are going mostly, to build more intelligent systems, either it's in manufacturing, production, or in more daily life examples. Most things, they are trying to be intelligent. They're trying to build more intelligence by using different methods, different processes, and different technologies, and so on. But on the other hand, the machines can still see one side of the picture. Not all the behavioral aspects are there, and there are still gaps in that way. And there are challenges in terms of the partiality of the machines and so on. And there was an interesting debate we had earlier with that how the machines taking certain decisions, how can you make them responsible for those decisions when with or without involvement of humans and so on. It's quite challenging in terms of legal aspects as well. But on the other hand, in terms of the use of technology, it depends how you use it. You can use it for the good. There are lots of good examples where things are going towards human augmentation, where you implant technology into human bodies and so on. But there are concerns as well. Some communities, there are various concerns into how that technology and the data generated by that technology is going to be used later on. But the main thing here is that we are moving from from the levels of data information to knowledge and understanding. So So for example, if we think about this kind of triangle, the pyramid. So earlier we had all data in terms of many different aspects, and we convert it into information, and then we convert it all into knowledge, and then it goes to further actionable understanding. So where you take actions or decisions in this part. So we are moving towards this top level, which is kind of the future at the end, but it's not there yet. So we are basically around this sort of moving from this sort of domain, from information to knowledge levels, and very partially going towards the further decision making tip. So we are just touching this one, but the future is towards this sort of space where most things are happening in terms of this space, where you can bring more and more intelligence into the machines so that they can act like humans in different aspects. So is this a future? Probably. You're embedding the technology into humans, maybe the human augmentation kind of hands-free technologies here. But it's a bit of question. What do you think about it? In terms of manufacturing domain, some of the future works we are doing in terms of characterizing different changeable and smart factories of the future, where the different Industry 4 technologies are within the scope, so that we can embed them into the factories to make them more intelligent. One example could be also to use the Industry 4 technologies into airports to make them airports 4.0 and so on. So based upon this, we talked about the human-machine interaction. In summary, the aim of this talk was to explore the future of human-machine interaction. And we talked about the three aspects and their linkage with the cognition in that way. So I think we covered some of the questions that we set in the start. We talked about the human-machine interaction, the challenges in their design, how we overcome those, and the future of the human augmentation. And I would be happy to take any questions at this stage, but thank you very much to all the students and colleagues who participated in different studies that we have been doing, both at Cambridge and other places. And thank you very much again for listening, and I'm very happy to take any questions or comments here.
Thank you very much, Tariq. I'm sure there will be questions.
Good.
Yes, go on.
Okay, so it's okay, Julia Maria?
Yes, please.
Okay,
yes,
no.
of course.
I don't know. You never know who you are looking, in Zoom. So.
Yeah. You are Matteo, right? I'm
Matteo. Yes, Matteo.
Yes.
Matteo Valeriani. Thank you.
Go ahead.
Thank you very much for this talk. I do have a few questions, remarks, or ideas, and so let's say I start with one, and then we'll see how far we go. I start with the cobots. It was very interesting, and in the moment you introduced the subject, however, you showed the cobot sort of in the laboratory speaking to the scientist or to the laboratory operator. Mm-hmm. So it seems like more than just pick and place, as you then showed later. I think there is a very profound difference between these two pictures that you've been showing to us. So the question is to you is, how far do you see the future when we will have cobots that in a way will interact with that laboratory operator or with that scientist, eventually, speaking or thinking loudly about ideas and what if we mix these two elements together or this kind of thing. So when do we go from determinism in the relation between machine and humans to something which is decisively related to, let's say, non-monotonic or divisible logic, so something which is more human indeed, also on the other side. Because also the example of Siri, if you will go one step less back in your talk, Siri, yes, is intelligent. Let's say mostly a little bit, not so not so great. Finally, but as a matter of fact, Siri works to give to satisfy a deterministic expectation that we have. If I ask where is the first bar close to my place, there is not much to think about. It's just, you count the meters. And if I ask something else, then there is no answer because there is no divisible logic behind it. There is no the possibility to argue, or I don't say to take decisions. I agree with you. The point to taking decisions is important, but it's important because it's driven by economy, because economy wants that to have that. But there are other possibilities. Decision is not the only peak that we could have. Imagine I could speak with a robot about the reasons of the decline of the Roman Empire. Wouldn't it be even more difficult than just taking a decision? But there's not taking a decision. There's no action. We just speak. So so how far do you see that future with the cobots? Yeah.
That's very interesting discussion, Matthew. Thank you for that. Just picking up on your first one, when you talk about the cobots, I think the main thing is about where you need them, where you use them, for which type of tasks you need. The robots have been there for a long time. They're not new. They have been there as rigid kind of machines which are caged and used for very high repetitiveness in terms of high speeds and volume and so on. But the cobots are there where you need more collaboration, more sort of assembly sort of tasks, where the safety limitations are not there as much, because you have to work with them more collaboratively, like you work with the humans. So you're comfortable in working with them as humans. But there are still limitations in terms of collaboration. So how good is that collaboration with the machine? Because machine needs to understand you, and you need to understand machine, that what machine will do when you do something. So there are multiple different types of possibilities that you need to capture into that sort of collaboration related intelligence which will come. And as that comes, that's how the speeds might go further afterwards. And you can give like more boring jobs, more repetitive jobs to the other side, where humans can more focus on their jobs rather than they doing the mistakes, for example. So that is one perspective. Obviously, you can see from that. But on the other hand, the other perspectives are obviously relevant, and we need to know where we need automation, where we don't need automation. Siri was not very good example in that way, because it depends how much you have trained them. So if you're not using Siri for a long time, you're not training it with your voice, it won't be good, right? It won't be that good because you haven't trained that. So on the back of that, obviously there are some models running which need some sort of training. But there are different contexts, and I think the debate is ongoing in terms of how you use these sort of technologies into the future, where the robots or the more automated technology would be intelligent enough where you can see that they can participate in different aspects close to the human related aspect, but still that is still far away. Even though we are looking at different developments, like the driverless cars is kind of a reality now. So we can see that that's happening in the near future. The loss of gigafactories are being built and run. So there will be driverless cars on the roads more commercially, even though they're already available at some places. But in next 5 years, for example, you might see more driverless cars over there. And similarly, these augmented reality, virtual reality sort of devices more common in use in manufacturing, for example. In last 5 years, 3-4 years, we have seen lots of drive over there, even though augmented reality is not new. It's there for last 50 years, but it's not being used that much. But I think all the other advancements into technologies have helped these sort of drives to go further, to push the boundaries in that way. I don't know whether I've answered your question or.
Yeah, I think so. But I first give the chance to.
Yeah, sure. Thank you.
Thank you.
Yeah, if there are other questions, otherwise I would have a question. Yeah, my question concerns deep learning, and somehow also what Matteo asked in sense of decision making, and being able to not just, I mean, a machine being able not just to take a decision, I have to drive straight away or turn left or turn right, you know, but also decision making in the sense of being able to have its own narrative, and having its own narrative in the sense of being able to take autonomously a decision. And I mean, you were quite right in explaining on which point we are in at the designing and developing. We are basically far away from decision making. But let's say research goes on, and I don't know, in 20, 30 years, even less, 10 years, we will have decision-making machines, meaning a machine able to accomplish a task for which she has not been programmed, so something which she needs a narrative. I mean, how realistic is that? And let's say it will happen. What my question is, will not always be a difference between humans and machines, in the sense that even if a machine will be able to have its own narrative, there will be always a human being or humans able to deprogram the machine. I mean, to switch them off. Yeah, this is basically my question.
I think that's an interesting question. So it depends what we mean by the decisions and so on. So because some machines, they are already taking decisions, the actionable understanding. So we tell them clear instruction, do this if this happens. So all sort of rule-based mechanism. But I think what I understand is we're talking about higher level decisions, the bigger decisions in life, where they are affecting more human lives and other aspects and so on. For example, in driverless cars, would the car save a life in case of, or if there are two lives on stake, which one it will save, you know? So how will it prioritize those sort of things? So all those sort of different situations that emerge, where it has to do more dynamic sort of decision making, where there are options to choose, where you have to apply your kind of thinking and other intelligence related aspects. I think those are quite challenging for machines to do, and that's where most of the research in that domain is happening and so on. The other things, what was your other question? Sorry, say again.
Yeah, my question was precisely on that. I mean, a decision making in which the machine would have to be able to decide by itself. Would be this decision based on programming still, I mean, on algorithms? Or one has to understand that a machine will be intelligent in the sense that she will be able to accomplish a task for which she has not been programmed?
So I think there are some advancements going on in terms of the algorithms and so on, which are becoming more powerful, and they can program, reprogram, and so on. But I think there are still lots of things to be done on that side. As I mentioned, that it's a partial view, because the machines, they do not act like humans as such. There are lots of other behavioral aspects and other aspects which are not embedded, the psychological, all the other different aspects which are not embedded into machines so that they can treat. And there are concerns in terms of the algorithmic bias as well. So there have been reports in different sorts of biases in terms of algorithms. How can you take those biases out? Even though biases are in humans as well, and we are still trying to take those out. We haven't been able to across the globe. But how would you address that sort of challenge in the machines? Can you embed that into take out those sort of biases and the algorithms which can drive the machines in one way or the other? I think there's a lot of things to be done on that space, which are still far from humans.
But I mean, in terms of engineering, would it is realistic to think you can always deprogram it? Doesn't matter how far deep learning or machine learning goes.
I think for now, yes, it is possible, but we don't know about the future yet. It's still far away, particularly because in manufacturing, I think that's not that big topic in terms of like giving the power to machines that much that they will become that much powerful. I think that's more wider out of the manufacturing domain, where it becomes more interactive with the humans in more daily life and other aspects in life. So in manufacturing domain, I think the main concerns are about making the things right. And if things change, for example, the disaster happened, right? COVID-19 happened. And similarly, other disasters happen, which creates all different sorts of disruptions. And similarly, disruptions happen within manufacturing domain as well. So assembly line breakdown, right? So something broke down, you have to change things. So how can you change that sort of decision making? You know, how can machines take their decisions like humans take in case of anything going wrong? I think that sort of intelligence, embedding that sort of intelligence into the system is kind of the driver at the moment.
Thank you.
Does it answer your questions?
Yes. Yes, it does.
It's an interesting discussion. So lots of interesting things happening nowadays.
I wonder if you have any examples you can think of robotic, machinic devices that are being developed now that take not the human as its model for cognition or for behavior, but take non-human animals or perhaps plant species, insects. So they are based on non-human models. I'm quite interested in that, and I'm sure that
quite interesting area. So there's a complete area of soft robotics, which particularly deals with making robots on the lines of all different sorts of insects or human or animals, for example. So they just copy what they are behaving, how they are doing things. So they will just try to make different robots based upon that. And there are lots of developments. So they copy different movements, different sorts of actions that they are taking, and so on. That's a complete domain. It's called soft robotics.
soft robotics. Okay.
Yeah. So there are lots of developments. Does it answer your question? I think.
Yeah. Sure.
Okay.
Are there other questions? I would have a question, perhaps a last question then, and it concerns those Robodogs, which has been developed by Boston Dynamics.
Yes.
And they have been implemented in Singapore for providing social distancing. But France is also interested quite a lot, actually, in implementing them as well. And this has to do with these new laws that they have to be approved concerning global security. And I wanted to ask you, Tariq, actually, I have seen some clips because a friend of mine in Singapore makes some records, and they sent it over to me. And I wanted to ask you, actually, how much developed they are in terms of AI.
I think
Because a very good friend of mine was in Parks there in May. And they were, and one of these dogs was in the park walking around, and as soon as he got very near to another person, it was quite frightening. I mean, to see these dogs, they are actually quite huge, going to them, advertising them basically to keep distance.
I think that's amazing to see what Boston Dynamics have been doing with the dogs and so on, and other different robots, and they seem to have been able to train them quite a lot and make the system designed in a way that can balance itself in different circumstances. I've seen some videos where they're training and testing them, pushing them all different aspects, and using them for different aspects, using for weightlifting, for helping in the construction jobs and other aspects as well. And I think that's a good development in that way. If that could be used for good purposes, obviously, and they're doing some good work.
Yeah, I mean, they are very good in sensorics in the sense that they detect distances, for example. Mm-hmm. And they are good, as you said, in movement. They really run.
Mm-hmm. Yes, that's right.
They can run and keep balance.
Yeah.
I mean, and they are also quite fast, actually.
Yes, they are. Yeah. I think there are other projects as well happening around the globe where different governments are involved who are working on developing superhumans and all those sort of Iron Man type of developments. So some of those projects failed in the past, but some are still on the way. So time will tell where things go in future.
But in terms of cognition, they are very, very basics. I mean, in the sense, they just have to detect a little distance.
Yeah, I think so.
I mean, like this, also like this other machine that you can use for surveillance or whatever with X-rays. I mean, basically they use X-rays, not nothing more than that. No.
Most technologies will be based upon starting from, let's say, vision-based technologies, because you have to perceive what is out there. And all these camera systems, the advancements in camera systems and how you can use them are helping way of perception, how you can better perceive the environment around you. And then based upon that perception, you process that information, and all these image processing and all the allied subjects and domains, they are advancing, they are helping in better understanding of those sort of different environments. And then that will help in taking the decisions what to do, basically, by understanding the context and how you behave in that particular situation based upon that you're using, isn't it?
So they really work based on vision recognition.
Yeah, those are technologies which are used, obviously.
Yeah. It's not just like an X-ray going around and then if you come in the area, they intervene.
Yeah.
Mm.
Of course, the basic technologies are there in terms of the motion control, and all the other structural aspects are there, how you design robots. Also being advanced, obviously, what type of motors to use, what type of other components to use, these integrity and other aspects are there.
Thank you very much.
Welcome. It's quite fascinating, quite interesting domain.
Yeah. Well, I must say, when it comes to those dogs, I find it also quite frightening.
Yes, that's right.
I don't know. I mean, it's yeah.
I think that question has been there for a long time, whether you use the technology for good or bad.
Yeah.
I think that's where we're hoping that the technology will be used for good, but obviously we need to prepare ourselves how to avoid mishandling or misuse of the technology for bad things.
Yeah.
I mean, the example I gave in terms of driverless cars, that could happen because it's a computer system. You're attaching all the algorithms and everything, and we see so many things going wrong in terms of the computer systems, people hacking and all the other stuff. What if someone hacks your car? What would happen? So that's a scenario, a risk-based scenario. I think those sort of challenges and risks are there, which are still to be future-proof in a way that you can ensure that it's a highly secure system that no one can intervene in.
No, this is also why I asked you how difficult it would be, for example, to deprogram them and to switch them off. I mean, in the sense, there is not only a responsibility in thinking about question that you touched upon, like automatic ethics and etc. How do I develop how do I design a machine that will have to decide? I mean, for example, in the case of driving car, do I have to kill 1 person or 5? What is better? I was not just thinking on that. I was just thinking also in the deprogramming aspect, because there is also a responsibility, an ethical responsibility in that, as you said. I have a driving car. I sell you that, knowing that there might be a person that could hack my system and bring me in danger. In such a limited case as driving cars, I'm not thinking about manufacturing systems or stuff like that, you know.
I think that's a topic for debate. So how best the systems are in place for that particular purpose. But when something is connected, then it's very difficult to ensure that that's hack-proof, you know.
Yeah.
So obviously you can put in place your systems and everything, high security and high redundancy and so on. So if someone tries to get in, how you can deal with that. It's kind of a scenario where someone is attacking on you, right? So how would you put your defense in there? How trained you are? So which means how you have trained your machines in order to fight with that sort of attack on you, right? So on similar philosophies, you can think about how best you have equipped your systems to fight with that sort of attack.
Yeah.
I think I have to leave. It's quite late.
Yeah, I think we.
Okay. Thank you again for the talk, and see you soon.
Thank you.
On Friday.
Bye.
Ciao.
Ciao. Ciao.
Yeah, thank you so much, Tariq. I think we will put an end to the session now. And I was a bit sorry that not many people joined, but perhaps they were scared by engineering stuff. I don't know.
Yeah, it's difficult in multidisciplinary topics. So how many people you get normally?
Now, usually we had 30 people attending. Then we have a classic lecture in which there were around 18. and then you today with 9.
Okay. So I hope everything went well. So in terms of the series.
But I think it was a very interesting for those who attended.
Yeah. Okay.